Juna. Or something. Sige. Ano muted na? Hello? Review session for IE144 LE1. Yeah, last exam before we head into egg week, I guess. So, here's how it's gonna go. We sent a questionnaire. I'm not sure if this was sent na. Uh, of the topic that the samplets that we're gonna go over. And yeah, this is going to be slightly different because I'm usually used to iPad. I'm doing this on the computer kasi maraming Excel work, right? So just makes more sense to do this on laptop this time. So bear with me if there are any technical hiccups. So let's just go straight into it. So conceptual questions, because they did mention na lalabas siya sa exam. So here's the first one, define simulation. So obviously this is open-ended. So what I'll try to do is just go over the concepts that are necessary to answer these conceptual questions. So first, defining simulation. Essentially, you want to include three keywords in your answer. The first is imitation. So it always copies. It copies what? It copies a real world system. And more importantly, typically it also copies it over time. Although not all simulations do that. So yung pinaka-important keywords dito is imitation and then real world or system, real world system, and then in some cases over time. So that's number one. Number two, give one advantage or a situation where it is appropriate to use simulation. These are the six that are in the definition. So this is how I prefer to memorize them. So this is really just recall if you remember the use cases. So when disturbance is not preferred. So for example, hospitals, when you have interactions between many entities. So it's obviously hard to do that in a simulate that. I mean to do that in a, let's say, experimental setting. Stochastic processes, verifying analytical solutions, experiments where direct experimentation is difficult or costly, and then if you want to have animations or visualization for like the solution you're trying to implement. So these are the six scenarios where it is preferable to do so. This is in the notes naman. Just a matter of memorizing. Third question. A spreadsheet simulation is done to simulate the queuing system in a bank. Random numbers are generated using LCM. The simulation is static or dynamic, and then deterministic or stochastic. The answer to this is dynamic and stochastic. Why is this the case? So recalling the static versus dynamic, the qualifying characteristic that differentiates one from the other is time. So for example, the result of a dice roll is static kasi it just shows the result of the simulation at one point in time. Versus, for example, the running average of dice rolls. If you rolled like one dice every second or 100 seconds, so like 100 dice rolls, obviously mag-iiba yung running average over time. That would qualify that to be dynamic. So that's the difference between the two. For deterministic versus stochastic, this is just from IE28. So it's just how constant is the output given an input. If the output is the same given the same input, it's deterministic. If it's varying, it's stochastic. So yun lang naman yun. I think this is more of just a matter of interpretation, whether or not you can interpret accurately. So I would say this one kasi you're simulating the queuing system in a bank. So that means na you're obviously working with service time, arrival time, etc. So necessarily you have to always factor in arrivals and departures over time. So by virtue of that, it's a dynamic process. And then uh, because you use the random numbers using LCM, like it definitely has to be stochastic. So yun lang naman yung interpretation for three. This is really just an interpretation question. Four, define random, there are two qualifying characteristics for what random is. The first is that it should have no pattern. The second is that it should not be predictable. So I guess to some extent, one follows the other. Pero those are the two by the book characteristics for defining random. Those are the two things that you need to mention when asked to define random. Number five, give the two statistical properties necessary for random decimals. So from 0 to 1, uh, there are two. So the first is independence and the second is uniformity. Uniformity just means that the set of generated uh, random decimals follows their uniform distribution. So in this case, there are two ways to test that, either by the chi-squared test or the KS test. And then for independence, runs up and down. So that's for number five. For number six, LCM is always periodic, true or false. The answer to this is actually true, which might be a bit weird kasi 'di ba, technically like supposedly LCM generates random variables and therefore it should not have a pattern. So meaning it shouldn't have a period. But technically, values generated through LCM do have a period. It's just that there are some combinations of yung parameters ng LCM, which is M, yung mod, M, AC, and X naught, which is the seed. They just have very long periods such that it would take like a very, very large amount of numbers bago siya mag-cycle ulit. So its period is very, very large. And essentially, when you run it through yung mga statistical test, it just shows up as random. So it meets the two qualifying characteristics. So sobrang haba ng period niya. Like versus the amount that we have to generate, which is like 100 lang, or in some cases 1,000, ganun. TLDR, it does have a period, it's just very long. At least ano, the good parameters for LCM. Number 7 and 8, we kind of mentioned those already. Just refer to number 5. So statistical tests that can be used to test for uniformity is the chi-squared test or the KS test. And statistical tests that can be used to test for independence is just the runs up and down test. Okay. For number 9, if random variables to be produced follow a continuous probability distribution with a cumulative distribution function that is difficult to manipulate, which random variate generation method is appropriate to use? So you might as well review the three methods discussed in class. The first is yung Monte Carlo simulation. This cannot be the answer because it only handles discrete cases. Second is the inverse transform technique, where we essentially take a generated random, be more precise, generated random variable R, and then you take the inverse of that by looking parang, so when you have uh a function like a CDF f of x equals something something, you're basically trying to isolate x. You're basically trying to isolate x, and that's what f negative 1 of R is. So the question stipulates that this is a very difficult distribution function to manipulate. So examples of that are the normal distribution. So you know naman what the CDF of a normal distribution looks like. Well, you might not know kasi we don't use it often. Pero yeah, we don't use it often because it's very complex and difficult to manipulate. So for that reason, we don't use inverse transform technique for normal distribution. So that's why, since it requires manipulation, can't be this as well. So by elimination, ito na yung sagot, acceptance rejection method. But specifically why this one also is because it can handle continuous distributions and it doesn't require manipulation of the the CDF to be able to create random variables. So essentially, ito yung method that has R1 and R2. Let's just discuss it a bit further while we're here na. R1 essentially acts as the x-axis, which will generate x star, which is the potential random variate, and then R2 defines the quote-unquote y-axis. So just to see a visualization of this, medyo low resolution yung photo. But what you're essentially doing is, R1 picks a random number along this line. I'm not sure if kita yung pointer ko. So along the horizontal line, R2 picks a random number along the vertical line from 0 to 1. And then this is your distribution of choice. So in this case, I think this is the normal distribution. Um, Essentially, if it falls graph here, then this is we accept this random variant. If it does not, we don't accept it. Assuming na we can create a random, like, more we fill in this like rectangular space, obviously it will be generally uniformly distributed. Like, assuming now we've proven that um from a prior test. Uh, Magkakaroon ka ng lots of random points here. Because you accept and reject on the basis of whether or not pasok siya sa line na to. In the long run, you will essentially have set of points that follow the distribution of the original distribution that you wanted to mimic, or you wanted to mimic. So yeah, TLDR, gagawa ka ng lots of points, and then you make sure that it's under the line. And that's essentially what acceptance rejection method is in case lalabas sa conceptual. So that's for number 9. Number 10, in the discrete event simulation, time is emitted except at points of events that change the system table, system states, true or false. This is true. So just so we can go through the jargon, then events just basically mean a change in state of the system. So kunyari, if the system is a queue, the event would be the arrival of a customer. A customer in this system is what you would call an entity at a certain time t. So at a certain arrival time, which is what you would describe as an attribute, something describing the entity. Um, and changes in the state just means change in state just means that something that describes the system uh changed. So for example, the number of customers waiting to be served, uh, where also service is equals activity. Kasi activity basically just means time period of specified length. So uh, like service. Yeah. So essentially, yun na yung lahat ng components of a system just interconnected. But going back to what was asked in number 10, this is just essentially true. So that's conceptual. Um, Siguro, wait, I'll pause here for a bit. Do you guys have any questions? Are there any questions on this theory? Wala na. Wala siyang none. Okay. Parang wala. Let's just proceed then. On to problem 2. Problem 2. So a 7-sided dice with 1,000 replicates. Use the rand function to generate random numbers. Estimate the mean and variance of the 7-sided dice. Okay. So let's just first estimate. Let's just first add the mean. The mean is just obviously just here para ano. 7 plus 1. It's from 1 to 7 over 2. So the mean is 4. So we expect a number near 4. And the variance is just tinatamad akong gamitin yung formula. So just as a standard dev, and then we just square that. So that's the standard dev. So 4 and 4. So I guess if you really don't trust yourself, you'll also just do this. Wala. Parang medyo extra siya. Okay. Let's leave it there. So that's the mean and the theoretical variance. So now let's generate the random points. Um, so let's just generate 1,000 samples. Ship. Okay. And then, okay, wala namang, okay, use the rand function is what was specified. So just gonna use that. And then I'm gonna set it in stone. Okay. So that's essentially our random numbers. Pero these are not, obviously we cannot use this kasi this is from 0 to 1 lang. So what we need to be able to convert something that a random uh variable that changes from 0 to 1 to simulate seven-sided dice with 1,000 replicates, we obviously have to create random variates. So uh going back here, I can we can make a table for what represents 1 to 7. So I guess I just show the how I prefer to go about it. So in this case, you'd obviously just add 1/7 to each interval. So and then reference the ones at us because obviously these have to be similar. So I just do it to be safe. Yeah, should add up to 1, and then obviously you want to get the random variant. So let's just look up. Uh, Let me just try to see if I remember. It's a problem if I don't remember. So we look up search key is just what we're looking for. Uh, range is uh, range is ano kaya ba tayo dito? Joke, hindi pa. If uh this has to be, so you have two conditions. You have two conditions. So maglalagay ako ng and dito. It's greater than this. Oh, wait lang. There's a faster way to do this. Uh, mhm. Sige na. Let's just do this. So and I'm going to lock this. Lock that, and then to this is really tedious, honest. Um, and it's actually an X. So the first condition value would just be this. Um, just repeat that multiple times. So I'll just copy paste this kasi magbabago lang naman yung row number. Let me full screen it. I don't ask question. So 14. About to do this. If I do run out of time, I'll just take the answer key and explain from there. But I'll try to make it step by step. This is 15. Then ulit lang. Oh my God. I'm fucking hate this. Whatever. Ulit. Oh wait. But I'll try something. So I'll bring it down. Ay, bobo. Same pa rin naman. Pero, so what this will do is like, no, it will not. Kumano-mano ko na. Sorry guys. It's because so ifs it's like much slower. I forgot the faster way to go. 14. Pero yeah, I guess it shows the process manually na rin. Essentially, you're just matching the specific cases to one another. So taking this should get ayan. Ah, okay. I made an error. Dapat pala ano to? Frozen din to. So um, let me just fix all of that. 14, 15. Because you're gonna just drag it down essentially. So yan. So those are the random variables. So just to explain this formula very briefly, essentially it just checks if the random number here is greater than the left hand side value and less than the right hand side value, it'll return this value. So pag greater than 0, less than 1, 0.14, it will return 1, etc., etc. So that will just happen for all 7 variables. So yeah, basically yun yan. Um, so now what we're just gonna do is check if it aligns. So let's take the average. Wait lang. For some reason, uh, yeah. Okay, so we get 4.023, which is quite close naman to the real thing. And then uh, successfully done it. So yeah, this one is like uh I think we've done this naman in class. So really the hardest part is just generating the random variant, which is just to have this table. I think it's possible to use VLOOKUP and array formula here. So if you want to shave off some time on a relatively simple, well, relatively one of the simpler questions, uh, I recommend figuring that out. So I forgot lang talaga. I was gonna demo it also, but I just forgot. Sorry. So yeah, as for problem two. Problem three, area estimation. Estimate the area of a triangle drawn in the figure below. Use the rand function to generate 1000 random points with x coordinates and y coordinates, both uniformly distributed from 0 to 1. Point A, point B, and point C are the following coordinates. So, I wanna try to explain this like instead na isa spoon feed ko. I wanna like try to see if you guys can, if I can explain it like parang bottom up in a way. So how do we try like how can we use like random variables to generate an area? So the way we can think about it, parang analogizing from this is we can estimate an area by taking the number of points that are quote unquote inside or quote unquote accepted over the total number of points. So that would give us a percentage of the points accepted. So that can also be a percentage of the total area, right? If your area is 1, then the probability of acceptance is equal to the area, if that makes sense. So what I'm gonna do is just like visualize it lang. Okay, it's not worth it. So basically, inside this area, if we can uh so the unit area of this, so from 0 to 1 kasi, from 0 to 1, from 0 to 1. So we have an area that we have a square that's area 1 by 1. So the total area is 1, meaning the quote unquote denominator is 1. And therefore, if we take the number of points accepted over the number of total points, then we can get an estimate for the area also, because that is also something over 1, right? So that's basically the approach that we're gonna try to do. Um, for cases where the area isn't 1, and I feel like that's how they will show it, bring it up sa exam. You just have to multiply. You just have to multiply by. You just have to multiply by the actual area. But in this case, the area is 1, so there's no need to do that. So the first thing that we'd want to figure out is write the equations of the three lines. The reason why you want to do that is for us to be able to determine where the line is, we want to first figure out ano yung shape na to. So this will require some LM geometry. I mean some high school geometry. So basically ipa-plot lang natin lahat ng points. Uh, So I'm not sure if this ones will be allowed during the exam because alam kong parang hindi. Pero this is also just for the purposes of visualization. Oh, sorry. Okay, sige. So now, let's use what we know about geometry to try to derive the lines between these points. So, uh, just looking at it here. Right. Ako, I would just try and error this to be honest. Pero sige, let's. Okay. So the first thing I'll do is just define the slope. So, kasi I'll just do it like y equals mx plus b kasi that's the easiest. So first, let's get the points between a and b. So a and b. So rise over run. That's just uh the rise is from 0.9 to 0.4. So 0.4 minus 0.9 over uh 0.9 minus 0.8. So that's essentially this. Now we just have to move it such that mapupunta siya dito. So I don't know, just educated guess. Let's try 0.9. Oh shit. Siya may subscript. Okay. That didn't work. So now let's figure out, I don't know, just honestly at this point, I'll just use test values. Like, medyo nakakatamad isipin. So, okay. Um, so we want to find this. So filling in test value for y and x. So 0.4 is equal to this times 0.9. So this is just uh, sagot ng B. What the hell? Okay, let me just solve that by hand real quick. Times 0.9 to 4 that's negative 4.5 plus 0.4. So 4.9. Okay, finally, version. Sorry. Uh, Ayan. So that's the equation. That's the line for uh A, B. So the reason why that's important is now we can relate the first random variable that we get to the second random variable we get, and then we can arrange this in a way na we can essentially infer kung what you call that. We can use this relationship to show that um like papasok ba siya within the area or not. So I believe in this case it would be less than or equal to. Yeah. So everything within that is part of the condition. I'll just use equals for now kasi it's a bit masakit sa mata. So that's for AB. We just replicate the process for BC. So for BC, the points are 0.9, 0.9. So 0.4 minus 0.2, and then 0.4, 0.2, 0.9, 0.1. Same thing, I'll just solve this by hand because I don't know why it's not working on Desmos. So using the test value 0.1, 0.2. So this is just, um, what is this? Wait lang. 0.25. 0.25 times 0.1. So 0.025. Uh, so 0.075. Okay, yeah. As you can see, kita naman, the points do coincide. Ay, it is not. Wait, I messed up some. Uh, so the points coincide. So sorry, arithmetic error. Yeah, and then AC, essentially the same process lang ulit. Uh, this is A, just use the test point 0.9 minus 0.1, 0.0, and then 0.8, 0.2, 0.2, 0.9, 0.2, 0.8, 0.1. Okay. Um, Now let's check where the no is. So I'll just use the same test point 0.1, 0.2. Yan. So that's positive 0.1. There we go. Okay. So yun lang naman. And then everything inside the area. So let's just see graphically. I think this is all less than or equal to. Tama. So it has to be less than or equal to this line. But at the same time, it also has to be less than or equal to this line. Greater than, sorry, greater than or equal to this line. And at the same time, it has to be less than or equal to this line. So yeah, um, I don't know if there's a way to visualize this. Basta this point where the three areas intersect is essentially our acceptance region. So yeah, um, now what I'm gonna do is actually start this process. So okay, so now I'm gonna do the same thing. Right? I mean, same lang naman. We generate na naman tayo ng um, random numbers. So let me just switch. Something's wrong. Let me just switch. And then lock the values by copying and then Control Shift V. So yun na yun. Now, as we mentioned, they have to obey the three equations that we set out at the same time. So, um, essentially, we have to check if they follow these constraints. So what I'm gonna do is just do if uh, y is less than or equal to uh, let me just get the values of the slopes. -5 times this uh, plus 4.9. Let me just add another bracket. So, um, oops. Uh, uh, for all three. I'm just gonna first. So within AB, within BC, within CA. Let me just check. Okay, tama naman yung notation. So same concept lang. We'll just change the slopes as we go. So we'll just change the condition. Ito naman 0.25. So and note that this one, we determine that it was greater than or equal to. Just be careful. That 0.25 plus 0.175. Ito na siya. And then plus 0.1. Oh, same was true. Ito na yung hindi na. Yan. That's why I prefer sheets also. So essentially, these are our set of points. Yeah, so hanggang 1,000. So all of them have that. And then the next thing is basically, as we mentioned, they all have to fall in. Basically, all these three conditions have to be true. So, so basically, we just check if all three statements are true. Fastest way to do that is just do this. Because you're multiplying three binary statements. All three have to be true or have to have a value of 1 for you to have this. And then, again, because the square that we're estimating has lengths 1 and 1, so meaning 1 times 1, 1, yung area ng square is 1. So that's our total area or total number of points. And then we just have to check the number of accepted points. So let's first check for the number of accepted points. This is basically just prefer this to also double check if tama yung range ko. Count 1,000. So tama naman. Just this over this. So this is 0. Is just area 1. So this is just basically times 1. Ito na yung area of that triangle. So yun na yung sagot. Just to go back a bit and TLDR. So essentially what we did, una is so this is just random number generation. I suspect sa exam they will ladderize this. So there's a chance na the generated points here are actually done through LCM. So just prepare for that. But essentially, we just generated an x coordinate and y coordinate. Tanggalin ko muna to. Essentially, it just represents points from this to this. So this area from 0 to 1 on the y-axis and 0 to 1 on the x-axis. Then we check, uh, if it falls into the area defined by line AB. So that's here, this entire area. We check, we found a way to represent areas within line BC, which is this, and then within area CA, which is this. Area like created by the line CA, which is this. So obviously, for them to be inside the triangle, these three conditions have to hold at the same time. So ibig sabihin, all three have to be true for us to quote unquote accept this point. So accept sa like medyo analogous to sa acceptance rejection method. So then we did that, right? So that's why we have zeros and ones. We counted all the ones that were one, meaning all three conditions were true. Out of the 1,000 points, around 204 were true, were accepted. Total of 1,000. And then essentially, because it says 10 replicates, so just be careful. All you honestly have to do is take this and then convert it back to run to equals run, and then you copy paste this. Sige, i-demo ko na lang din. So, we run the simulation for you. Kasi every time may ginagalaw ko sa sheet, nagbabago yung values ng run. So, as you can see here, like 0.214 pala to. So you can see, nagbabago siya. So just pick this off. 1, 2, 3, 4, 5, 6. 8, 9, 10. So yeah, and then you average that. That's the answer na to the question. Using 10 replicates, estimate the area. So using our 10 replicates average, it's 0.2117. I don't know what the true answer is. Base time set lang naman natin. Although finding the base is hard. So I don't know if we'd have the time to counter check in the real exam. Malapit naman siya sa answer. So whatever. Okay. Next problem. Problem 4. So this is the inventory system. This was the one na medyo challenging, at least sa Ma'am Thea sections. So hopefully we can learn something from this. So this is a long read. So Hi Toys Incorporated is a high-end shop which sells toys every day. Daily customer demand for toys follows a discrete probability distribution as shown below. Hi Toys Inc. has the following inventory policy. Their ROP is 1, which means they will reorder at the end of the day if the stock is 1 or less. The reorder quantity is 2, which means 2 units are acquired every reorder. Lead time for order is consistent at 1 day. So this is slightly simpler than the lab activity, which means that if an order is made at the end of the day, the ordered quantity will arrive at the beginning of the next day. Stockout can occur if a customer demands toys and there is insufficient stock. If current inventory is less than demand, toys are sold until 0. The components of inventory cost are as follows. Holding cost is at 500 pesos per unit per day for all units unsold at the end of the day. Ordering cost is 1,000 per order and stockout cost is 1,500 per unit of lost sales due to stockout. Compute for the grand total inventory cost. So we want to simulate 100 days. We want to simulate 100 days of operations. In generating random numbers, use LCM with seed 218, A 65539, C 13, M 2147, 48, 3647. Make sure you have columns for daily demand. Okay, let's So make sure you have columns for the following. You may add other columns, but these 5 should be clearly seen. Assume that the beginning inventory at the start of simulation is equal to order quantity. So order quantity here is equal to order quantity as in 2. Yeah, order quantity is 2. So let's just check. So the first thing that I want to do, just so we're not confused, is just generate the random variables first. So okay, so let me just list the parameters down. Uh, A is equal A is equal to 65539. C is equal to 13. M is equal to 214,748,3647. So now we have x naught, which I will just put here, 218. So to get the first replicate, we first have to take x naught times, so we have to take x naught times A plus C and then take the modulo of that. So kasya yan lahat sa modulo function. So the first thing is the dividend, which as we discussed is just x naught times A plus C. So I'm just gonna encase that. And then our divisor or our M is just this. Okay. Then to generate the random number, it's just equal to this divided by M. Yeah. How many days? 100. Okay. Cool. So this is day 1 now. So same old procedure. Just prefer to do this. Medyo weird. Pero whatever. 100. Shit. What happened? Oh. Plus 100. Oh my god. Oops. Okay. So then just turn it on. So 100, and then essentially we do the same procedure. Oh, I made an error. Dapat fixed everything actually. Everything should be fixed. Sorry. And then M should be fixed here as well. So I'm clicking F4 lang for those who forgot. Now I overfixed it. I joke. Um, Control shift. Yeah. So that is the random numbers. And then essentially just do the same here as well. Okay, so those are our random variables. In test naman these range from 0 to 1. Another side comment, I feel like there's a chance that they'll make us do as well. They'll make us do testing for whether or not this is independent or uniform or whatever. Because I'm pretty sure they will ladderize the questions para onti lang yung items sa exam. Hopefully. Or I guess not hopefully. But yeah, just be wary na from this point you can also do statistical tests to prove that this is a random set of numbers. Yeah, so sige. Now, um, this is our random variable. So this is our n. This is our x. Now we can use a table to convert this into demand. So demand variable is just to sabi discrete probability distribution. So just to convert that, start from 0.6. Start from 0 to 0, then you know, I'll just do it normally, 0.6. It's plus 2, 6. Then this is just equal to, then this is just equal to this plus, I prefer to have it connected, but I just gives me confidence that if I fucked up somewhere, kita siya agad. Then should add up to 1. Okay. So let me just next we just fill in the demand. This is the same procedure as we've shown last time. Trying to remember if I no. It's too convoluted. I'll just do it normally. Ifs random number greater than this. So this is and then less than this. And the value should be this, right? So if it's greater than 0, less than 0.6, or sorry, greater than or equal to 0, less than 0.6, should be F3. And again, this just repeats. Let me fix the appropriate values this time. Okay, this should be ready to just copy paste. Luckily, three conditions lang naman this time. C10, C9 pa rin. D, 4, E, 4, F, 4. Same thing, B5, E5, F5. Oh shit. Include the and sa pag-copy paste. Sorry. Okay. Okay. Just copy this downwards. Sige. Mukhang tama naman yung pinaggagawa ko ata. Let me just consult yung code. Singular is 3, 2, 2. Okay, looks good. So sabi our beginning inventory. Beginning inventory is 2. Kasi sabi dito, assume that the beginning inventory at the start of the simulation is equal to order quantity. So just set that as 2. So our ending inventory is obviously just beginning inventory minus demand. Okay, sige. I'll let you guys in on something. So there's a faster way to do this. You can use array formulas. So when we do array formula, E9 to E108, I think 108 was the limit, minus D9 to D108. Uh, Essentially, what we are doing is taking E9 minus D9 and then outputting it on F9. And then it will also auto output on F10 E10 minus D10. So once you do that, ito. This is controlled by the formula at the top. I think some of the, I'm assuming like the Intel people or the pub people know this. This is like Excel. Basta yan. Just for, I don't know, additional information. Obviously negative to kasi zero pa to. Pero that we'll fix that later. Um, so what are the two indicators that we need to show? Ano yung 5 columns? Okay. Stock out and total inventory. So stock out essentially just means it's just by how much yung kulang. So stock out is just, so una, this will only trigger if negative siya. So ayan, sorry. The additional thing here is kailangan zero siya because it was ending inventory obviously cannot exceed zero. So you have to add another condition if greater than zero, then it's just this. Otherwise, it is zero. If it's less, yeah, okay. So in this, what this is basically just saying, medyo convoluted lang siya tingnan is, if beginning inventory minus demand is greater than zero, then it's just beginning inventory minus demand. But if it's less than zero, it is just set to zero because obviously you cannot have zero negative ending inventory. And then we're just gonna reuse the same equation for stock out in the sense that if it is less than zero, we use the equation, we use the E minus D kasi that tells us by how much nagkulang yung stock. But if it's greater than zero or pag zero siya, then just use zero. So ayan. Dito na lumabas yung negative. Obviously, since wala pa tayong beginning inventory for the rest, ganun pa yan. So then, for reorder, obviously kung our reorder is triggered by the reorder point, so our reorder point is 1, meaning same thing. Let's just use our formula. Tinatanong ako. H9, H108. If this is less than 1, true. If not, sorry. If true, otherwise false. Alright. No, no. This is dapat sa ending inventory. So that's F9 to F108. Sorry. And then let's just take our, so we have the following costs. Yung una is yung holding cost, 500 units per day. So this is just in ending inventory times 500. Yeah. So that's holding cost. We also have ordering cost. So every time mag-order tayo, wait lang, this should be two. Okay. Ordering cost, every time this is true. So since true takes a value of 1 sa Excel, I can just do H9 H108 times ordering cost is 1,000. There. So don't mind mo na yung baba. That'll fall into place later. Stock out cost is just stock out. So G9 to G108. Uh, so stock out cost is 1,500 per unit of lost sales. Okay, and then TC is just total cost. This is just a sum of so I, J, and K. So I9 to I108 plus J9 to J108 plus K9 to K108. Ayan. So it just adds all the costs together. Oh, sorry, I forgot. Dapat negative to kasi yeah, otherwise magka-cancel sila. So yeah, that's also the other benefit of our formula. You don't have to worry na kung mag-edit ka sa taas, baka makalimutan mo mag-edit sa baba. It applies it to the whole equation. It's quite convenient that way. So yeah, we're not quite done obviously. Di pa natin na-model yung beginning inventory. So yung sabi dito is, the lead time of order is consistent at 1 day, which means that if an order is made at the end of the day, the order quantity will arrive at the beginning of the next day. So meaning, sa day 1, if nag-reorder tayo, darating siya at day 2. So, what this means is na uh, I can also just use an array formula here. This H 107 kasi hindi nakasama yung pinaka-last plus okay. And foresee a problem. Plus, if true, times 2 kasi that's the reorder quantity. Oh, sorry, not beginning inventory, ending inventory. Um, wait, sorry. So ending inventory plus nagkaroon siya ng y. Okay, I'll just redo this whole thing. Tanggalin ko yung array formula. Apparently, it's creating problems. I mean, just a matter of removing this, and then you just basically have to fill it in manually. Oh my God, really? Ah, okay, luckily it's not that hard to undo it naman. It's just time consumed. So medyo nag-backfire yung plan natin to save time. Like surely now, no? If reorder is true times. So magpa-plus 2 ka plus yung ending inventory. Okay. Oh my God. Okay. Ayan. Hopefully, this should be okay. Stock out. Reorder times 2. Kasi for every reorder, mag-add ka ng dalawa. Thank you God, bro. Okay. Right. Yan. So, that's basically it. So what we did, TLDR, oh, parang may issues pa wait lang. Uh,
Kumbaga yung malapit sa
okay. Seems like
So, let's say, kumbaga sa territory and sa answer. Hindi ko parang mas close yung relation. I don't know.
sige, let's just summarize everything kasi medyo maraming nangyari. So una, we first generated a set of random numbers. So we did this using LCM. I also forgot there are two types of LCM, but we weren't able to go over that now. Essentially just this. So una, we create. So it's A, it's X, the previous X. So in this case, yung seed X naught times A, and then parenthesis yan, then plus C, and then modulo M. Sorry. That's what it looks like. And then you take the value that you got, divide that by M, and yun yung lalabas. You do this for the next 100. We used yung variates to convert the random number into demand using this given probability distribution. And then once you got demand, we started with a beginning inventory of 2 as per question instructions. And then ending inventory is just beginning inventory minus demand. Kung lumagpas yung demand over beginning inventory, then we had stock out. And we also had a provision here na ending inventory obviously cannot go lower than 0, which is why we have this. If it is the case that ending inventory is less than or equal to 1, then we reorder, otherwise we don't. So kaya true. And then we just applied the costs as per stated. So holding cost 500 per unit, kaya nakatay siya to ending inventory. What is OC? This. Sorry, OC is ordering cost. So this is tied to if you reordered. So if true, magiging 1 yung value. If false, magiging 0 times 1,000. And then stock out cost is just the stock out value. I-negate mo siya kasi parang magne-negative siya. Or alternatively, you can set the negative dito if you prefer. Pero yeah, we'll just leave it at that. I-negate mo siya times the stock out cost, which is 1,500 per unit. And then the total cost is just the sum of that. So ayan. So what's asked in the question? Una, determine the grand total cost. So 12722. And this one.
Let's go.
Okay. Yeah. So that's basically the total cost. Check ko lang if tama yung last few na. Check mo tama na. Could we generate to? Okay, so that's the answer to number one. For number two, ano yung nakalagay? Count the number of reorders in the current setup. This should be, sabi ng hint, 2 digits. So, count if the orders, and then count the number count the number of stockouts in the current setup. This should be a 1-digit number daw. Okay. Dito naman is count. Okay. Count if uh, 4. Okay. So number of stockouts is 4, and then suggest better values for reorder and uh reorder point and order quantity. This is just the equation. Sorry, let me pull up. Dapat kabisado ko na rin to. Pero unfortunately not. Uh, the reorder point is just Q. Q star equals 2 ds over H, where D is the annual demand, S is the ordering cost, and H is the holding cost. So let's just calculate that very quickly. Uh, so square root of 2 times the demand, is the annual demand in units. So in this case, wait, annual demand for the okay. So annual demand, uh, okay, uh, is 1 times 0.6 plus 2 times 0.3. So I'm just getting the weighted average plus 3 times 0.1. So 0.78 times 360, we get 280.8. So that's the yearly demand. The ordering cost per order is 1,000. And then the H is the holding cost per unit per year. So in this case, the holding cost is 1,000, but it's per day. So just 1,000 times 366. What 360? 366. So then this is just square root of 2, sorry, 2 times D times D times S over H. So a better uh, order quantity is actually 3.94, or estimate around 4. The other way you would do this is by simulating everything and then checking the checking the thing, like checking kung which one yung mababa after whatever number of trials. Okay, so I guess we're on pace to finish the whole thing. It's good kasi this is a past exam. Sige, let's just do this. Difficult queuing system, 20 points. Simulate the following queuing system. The recruitment process of Shophouse is a queuing network. Applicants arrive randomly according to a Poisson process with a mean 2 per hour. The first step is a written examination, which is always constant at 15 minutes. The second step is an oral interview, which has a time uniformly distributed between 20 and 30 minutes. As a queuing network, an applicant arrives into the first station, waits if there's a queue, undergoes the written examination, immediately arrives into the second station. Uh, wait lang. Lipat lang. Moves into the second station. Uh, and if waits if there is a queue, undergoes the oral interview, and then finally departs. However, only 50% of applicants pass the first step. Those who do not pass the first step immediately depart the system without going into the second station. Simulate 50 applicants arriving at Shophouse Inc. You will need 3 sets of random numbers. The first set is for applicant inter-arrival times. Use LCM with the following parameters. Second set is for the uniformly distributed time. The oral interview, use LCM ulit with the following parameters. And then the third set is for the probability of passing the first step. Use LCM with the following parameters. And then the CDFs were given for us. So answer the following questions. What is the total simulation time? Etc. etc. Okay, so we'll just need to set this up first before answering the questions. So this is quite tedious. So I guess bear with me. Medyo, let's just tipirin na natin yung time. Since we already have this algorithm, this will work for all numbers. So I'll just copy paste. I'll copy paste this, and then I'll just change the parameters. I know it's a bit medyo madaya, pero para makatipid din tayo sa time. Wait a minute. Hmm. Okay, okay. I should have aligned it. So just change the parameters, and then I'll just copy this 3 times. So yeah, this is why my suggestion also would be to do your solutions cleanly para, or at least clean enough na you can just repackage them. Kasi yeah, LCM for example, lagi mo naman yan gagamitin. So you might as well take advantage. Okay, so what is our figures? Dito x naught is 543. A is 65541. C is 9. And then M is, I'm just gonna copy paste, baka magkamali pa ako. Second set is for the uniformly distributed time of the oral interview. Same thing, 128. 65543. C is 4. M is, oh, this very large number. Okay. Third number is, oh my god. X naught is 713. And then A is 655 or 5. And then M is this very large number. So I'll just copy it. Okay. Parang napansin ko. Okay, ayan. Running to an issue. Yeah. Okay. So I have to ano pala. I have to first remove yung locks niya based on column. Kasi otherwise hindi siya gagalaw at all. Oops. Okay, di naman ata uulitin lahat. Ito lang, pababa. Okay. Fine. 7:03. Okay. So that's the LCM. Relatively quickly lang because we've already done it. This is the same exact procedure. We just reused the equations. So this should be relatively straightforward now. The next thing that we're gonna do is actually build the queue. So now we have the random variables. We have to convert them into random variables. Okay. The first one is just the probability of the the amount of time to do the first step. So let me just verify first if tama yung ginawa ko. Oops. Okay. See, now we can go to the inter-arrival time. Okay, so the first thing that I'm gonna do is just get the uh inter-arrival time. So when do they arrive? Uh, the way I'm gonna do that is so recall yung uh inverse transform of the CDF. Um, I did not recall, so I'm gonna try to derive it. Uh, one minus R over
Things before
wait, shit,
I think kahit
over
kahit competition different times
lambda
someone put me
lambda.
yung what are our new rankings from like
Ito ba ito?
want to
Wait lang. Sorry, down. Teka mag-check sa code.
After reading it,
also review for me.
I can start with this numbers people. So after watching the video, parang weird, it's a weird thing. Pero it's mostly grounded technique. Dun sa isang topic na naman. Isang na topic, idea. You know, it's regarding maintenance of data. Like,
So that's the inverse transform.
because we're all part of this.
So essentially, let's take the first
field.
random variable.
Like everything is a first.
Well, first let's get lambda pala. So lambda here is 2 per hour, meaning na okay, everything else kasi is in units. Yung oral interview, yung examination. So let's just convert that into hours. 2 per hour means 2 over 60 per minute.
We're not the only ones doing that. Or rather, we're not the only ones
So that's our lambda.
in this.
So we can just plug that in. Negative ln,
And since everything is the same,
negative ln,
everyone's the same.
1 minus yung R1.
Quantity. I have no ranking. That's my take on it. Like, I have no, like, they're all equal.
Over
So for me, like, if ever we're gonna make it, like, yun yung suggestion, if ever we're gonna
fix that.
get into a posted, I would line them up in a single word.
Alright, sorry.
In at least in the context of the ecology. everything
Seems
is
like
equal.
ito na yun.
Everything's equal. And
Okay,
so
so
actualization nila will come as it
this is our
every,
inter-arrival time
like it seems
in minutes.
it's
So
meron siyang
I'm just gonna replicate this for the whole.
but I hope you guys get the
I'm just gonna replicate this for the whole thing. So we have 50.
yeah, everything's balanced, everything's equal. So that's my performance.
Okay. So yun yung inter-arrival times nila. All pa siya 58. Yeah, somebody is talking. Uh, wait, guys, do you have access? Kasi Tristan just messaged me na ang daming pumapasok na request. With reviews FM right now. So I can't do anything about the other sounds. Okay. So reading. Tawag yan. Where were we? Sorry, distract now. So this is the inter-arrival time. So in minutes. And then this is the inter-arrival time in minutes. Sige, if you guys are struggling to access the file, request daw right now. Tristan will approve everything. Okay, sige, let's continue. So, yun yung inter-arrival time. For stage 1, sabi, ano yung sabi? In stage 1, sabi there is a constant at 15 minutes. So this is just joke. Hindi ko siya magawa. Basta 15 yan. Tapos, okay. So that's 15. ST2. So station 2. Station 2 naman, it's uniformly distributed. So second step, so between 20 and 30 minutes. I realized medyo ano pala to, sensitive topic for the for the third years. I hope you guys are doing well sa ano, internship search. So uniform CDF, ano yung inverse transform niyan? The inverse transform for that is, oh my god, these are things I should also memorize. Maganda to. Basically, it is XA plus B minus A times R. So it's the lower value. So the way I like to think about it is it's the lower value plus the lower value plus the range between the two values. So 20 and 30. So this is 30 minus 20. Plus I times R, which is the random variable. So hanapin natin siya dito. S9. F9. Let's see. Parang may small issue. Bakit siya? Bakit siya lumalagpas? Let me try to check. Okay. So, we didn't fully fix the problem. Kasi so obviously dapat walang lalagpas ng 1. So let me fix that right now. Okay. Hopefully wala nang weird values. Buti na lang napansin ko yun. But that's my bad din naman. So that's the second station. So now we have the first part of the queue. So let's just build the first part of the queue before we proceed. Actually, isa lang naman yung part of the queue kasi I joke, may ano pa, or hindi. Wait, let me think about the approach. So station 1, station 2. So these are the variables na. Um, Next up naman is whether or not they will actually proceed. So that's what we want to check. Uh, so I guess it's kind of arbitrary, but I guess it's much more sensible to just go if uh, random num variable greater than 50 true, otherwise false. And then 9 to 58. Uh, but i-array formula ko na. Sana hindi siya magka-problems. Seems like there's a problem. 0.50. There we go. Okay. So, wait. Okay, I just wanna make it consistent with the answer key para sige. So, uh, so now, we can essentially determine yung arrival time. So the first thing that I want to do is check for the first part of the queue muna. So station 1. So arrival time. Arrival time is basically just arrival time is just the first station lang naman. So that is this one. And then after getting the arrival time, we get the service start time. So the service start time here is obviously ito lang kasi first case pa naman to. And then the service end time is just service start plus time in station 1. And then the waiting time is basically just the difference between service start and arrival time. This case, obviously, it's 0. Yeah. So that's what we care about pa naman so far. First part lang. Second person, uh, previous arrival time plus the inter-arrival time. So 2.8. Time is basically the smaller of the two values. So min service end versus arrival. Sorry, max pala. So the longer time. P9, 10, and then service end is just this, wait, tuloy-tuloy na 'to. So, just this until O58, and then K9 to O58, right to K58. So, okay, never mind. Nagkaka-circular dependency siya. So, we have to do it manually. Uh, okay. So, that's service end. Same thing here. Ano lang 'to. So, then, uh, arrival time is essentially same pattern lang din naman. So, I think we could essentially map out na the entire queue, the entire process. Ayan. So, then waiting time is the same formula as well. So, ayan. Okay. So, looks like that's the ano, that's the that's for system 1. Um, for system 2, so again, 0.5 lang yung chance na medyo magfa-factor na dito if papasok sila sa second round. So, just so it's a bit visually easier to see, I'm gonna try to um check yung ano, I'm gonna try to check like if they proceed to round 2, then I'll factor them in. So, okay. So, yung uh, okay, so let's try to see how we can go about this. Same thing, same equations. So I'm gonna first start by playing around here. So arrival time, so service and normal because the first person arrived. Pero since the second person didn't arrive, how do we deal with this? Wait. Um, yung service pala is different because this depends on, so first thing I'll change muna is the service end time. This is dependent on the value we got here on the second uh second station time, which is this. Time is obviously the service end time from the previous one. So ayan, this is how it would change. Uh, and then obviously mag-iiba din ito plus arrival time, or sorry, no, its arrival time would just be same din dito. Pero kasi if false siya, uh, let me think lang. Hmm. I'm a bit stumped then. Like I'm doing this, ano kasi, kind of raw dogging it. Uh, so hindi, parang magsa-stand still lang yun. Okay. One approach that I'm looking at is if this value is false. So, sige, try ko lang. If this value, what the fuck? If this value is true, the value if true is just this. The value if false is just uh the value above. The reason why I think that can work is, yeah. So now what essentially happens is, kasi we cannot skip rows, right? Well, I guess you could skip rows din, pero like if you filter na only yung papasa to round 2 yung i-consider. Pero what this does is, essentially if they didn't pass round 2, uh, I didn't make it to round 2, actually just make this void. So hindi gagalaw yung arrival time of the next person, if that makes sense. So I'm trying to see if this is an approach that can work. Uh, is yung paggalaw ng ano. Um, so now, to remove service start time, to just basically factor it out, what I'm gonna do is basically put this inside. Yeah. So then service end is, uh, I'll just do the same. So what I'm trying to achieve here is essentially, kasi you still have to retain the information of the previous person who passed. Pero you also need to make sure na the person who doesn't pass, their parang their results or their arrival time parang doesn't get counted at all. So I think this is one way we could do it. Um, pero kasi still have to factor in their inter-arrival time. Hmm. Let me just test this out. Uh, oh, okay. Siya. Uh, wait lang. Let me just verify everything first. Each. So, eh, may parang issues ako. Oh, wait lang. I think may mali lang sa values ko. Give me a few seconds. Wait. Oh, okay. Mali ba yung kopya ko ng ganyan? Yes, mali yung kopya ko ng ganyan. Oh my God, sorry. So, okay. Um, so essentially, okay. So the next issue that I have is yung arrival time in person. Let me just check if this adds up na. Oh, okay. So the only mistake here is I have to factor in na, okay. So I think you can't factor in if they pass or not sa arrival time. This has to be fixed. Kasi otherwise it'll mess with the entire arrival time. So ganun siya. And then the service start time is just the maximum between these. Okay. So if you pass, uh, so in this case, hindi siya pumasal. So, okay. Uh, I think it should make sense. Okay. 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 I think I'm starting to get. Um, I'll explain it naman after. Uh, after this, uh, what I'm trying to do. Okay. So slightly more complicated lang sa round 2 section. So I've kind of figured it out now, I think. So um essentially, kung mag-proceed siya to round 2, so let's say the first person through case to, the arrival time is just, well, either way, it'll quote unquote arrive at station 2 at the same time it departed the first station. Pero obviously, different na if they get served or not. So in this case, service start time, if you look at this one, if they don't, if R10 is true, so in this case it's false. If it is true, then you get the maximum between the two, because that means that service actually happened. If service did not happen, then you just take the service start time of the previous. So yeah, actually I think this should be ganito. So yeah, then service end, so same condition. If they did actually proceed, then service start plus arrival time, service start minus plus sorry, service start plus the actual duration, which is the value here, right? The station 2. Um, i-add mo siya to get the service end time as per usual. And then what you'll notice lang here is if they don't proceed, so pag false, medyo static yung values, hindi siya nag-change. The reason why we want that, is because uh the reason why we want that is because this makes sure na the next person, um, the next person's start time isn't affected by the end time of somebody who didn't proceed sa queue, right? So essentially yun yung nangyayari dito. I'll just share this file and I'll also just share the answer key so it makes a bit more sense. Um, yeah. So, ayan. Going back to the questions, what is the total simulation time? It's just 1369 minutes. What is the average waiting time? Ay, sorry, di ko pa pala nalagay yung time in queue. So that's just this one. So, pero obviously in this case, it's just service start minus arrival time. So,
Wait,
okay. So may erroneous cases for the ones that don't pass. So just make that maximum 0. So ayan, lalabas yung waiting times. Yeah, we expect obviously much lower waiting times naman talaga for these parts. For the second queue kasi hindi naman lahat magpo-proceed to the second queue. Right? So, sige. If there's anything wrong pa, I'll just make sure to send a correction. But yeah, so that's the setup for this total simulation. So I'll just wrap this up. Total simulation time is this. This is the last timestamp. Average waiting time in queue for the first one. Is just the average of this. So yeah. And then this is the average waiting time in the queue for the second station. Same thing, i-average mo lang ito. And then what is so thinking of reverting the first and second station, i.e. oral interview before examination. All else is the same, including the probability of passing the first step. Recalculate the values in 1 to 3. Is this a good idea? Why or why not? Okay, 2 hours lang kasi yung time natin. The exam is longer naman. So, but anyway, for this part, just so I don't, sige na nga, I'll do it now. I was gonna not do it kasi 2 hours na, pero sige. Essentially, you will just swap these naman. So, I'll make, and then, swap ko siya. Stay, and we'll just basically have to recalculate a few things naman. Pero I have a feeling hindi. I joke. Yung arrival time pala. Yung arrival time will stay there. Yung waiting time yun. Yung everything else yung lilipat. Okay. So, you just have to refit a lot of the equations. The service start time is equal to N9. And then service end time is wait, actually, check. Oh my god, na-realize ko. Mas mabilis pala if we just change this part. So yung service end, instead of station 1 time, just add station 2 time. Ito lang pala yun. Sorry. So that's the fastest way to switch it. So ayan, na-switch na yung service time for S1. And then same thing sa service end time dito. Instead of adding this, mag-add ka ng X na 15. So, ito na yun. And then, yeah. So, nangyayari, isaswap mo lang yung dalawa. and then you should get the final answer as well. So just checking, is this a good idea? So comparing the waiting time from the first one to the second one, generally tumaas siya. Sorry, hindi ko siya na-note kasi hindi ka duplicate. Parang hindi ako nakagawa ng duplicate. Sorry. So, this is the second case. Generally, tumaas yung waiting time. So, second one, sobrang bumaba yung waiting time actually. Sa second station. Pero sa first station, sobrang tumaas. So, this is generally, adding them together, not a good idea. Kasi, nagbo-bottleneck ka sa first station. It's not good. So, the conclusion here is just, not a good idea to have it. So, yun din yung value sa 1 to 3. Total simulation time for this one is 1387 versus 1369. So the amount of time it took to serve 50 people actually increased. So ayan. That's the last item. I believe nagka-error talaga ako sa second queue. I will recheck this and send it to Lisa.
Hello,
Anyway, I have
everybody.
Pero hello.
Hello. Sorry to interrupt,
Hello.
but we have an EXICA meeting in a
Oh,
while.
yeah.
Yeah, sige.
Yes.
Bye-bye.
Sige. I'll just wrap this up.
Okay.
So, ayun lang. That's everything na. If you guys have any questions, just reach out. Thank you. We have to dip. We have a meeting. Yun lang. Thank you guys.